My name is Dick Cicchini. We're going to be going over the advantages of 6G over 3G storage architectures. Okay, we're going to cover what is 3G and 6G, what are the bus differences, what are the real drive differences, what are the performance differences. I think that's going to be your bottom line. And when is 6G justified? We'll be showing cost differences and so forth, and I'm not going to make that decision for you, but I can present information that will help you justify a 6G upgrade or purchase of a new subsystem. 3G and 6G covers two different storage bus technologies. So right now you have SATA camp and you have the SAS camp, and everybody thinks of SAS today as 15K drives, and 7200 RPM drives are SATA drives. Well, the reality is SATA 2, which was a 3G or 300 megabytes per second technology, now has available SATA 2 and 3, which is a 600 megabyte per second technology. And at the same time, what used to be relegated 7200 RPM drives used to always be SATA. Now SAS drives are available for the lower spindle speeds. Some people like to call it nearline SAS. I just think it's an expansion of the capabilities, and it's recognized that within the SAS confines there's a requirement for lower performing high capacity drives. All right. I mentioned SATA. SATA stands for Serial Advanced Technology Attachment, and it's born of the old parallel ATA. And that was actually born of the old PC ISA bus technologies. You used to have proprietary, you had controllers that had to convert from the PC bus to command structure to drives for old standards such as ISA and ST506. And they said, hey, let's take this technology and stream it so we can within practical limits, use that command structure and pass it through without delay or massaging of the commands and data. So that's kind of how SATA was born. Initially, SATA 1 came out. It was a 1.5 gigahertz product. And if you did your math, you'd find that came out to 187.5 megabytes per second. However, there's a certain amount of encoding that's required, so it works out to at a real-life bus maximum speed of 150. We grew to SATA 2 and 3 gigahertz, 3G. Nobody referred to SATA 2 as 3G. Now SATA 3 comes out, and it has a bus speed of 6 gigahertz, and you're going to see SATA 3 thrown around as 6G. I like to say SATA 3 so I keep it within the confines of what people are used to. And the other thing that you would see was, and this is where it gets confusing, you see 150 megabytes per second, that was SATA 1, 300 megabytes per second, SATA 2, and 600 megabytes. Very rarely did they reference bus clock speed in the SATA world. Okay, SATA has got it's grown and it's added features. The first thing that happened that revolutionized everything is you had a single. It's a serial drive with a much smaller cable, lower conductors, 6 conductors versus over 30 for the old parallel technology. So we simplified cabling. We don't have wide cables anymore. Cooling was more efficient. The other thing is now that plug is hot pluggable. The ground connections are a little bit further forward. So when you slide in a connector, you slide it into the backplane, you get a ground reference and then you bring signals on. So now we didn't have to have special drive sleds with intermediary connectors and so forth that could take care of that. SATA 1 introduced smart drive technology. In PATA days, and it has been upgraded, but earlier drives that were considered desktop-esque they could basically say, I have a read failure, I have a write failure, I have a seek failure. It wasn't very robust. The SMART technology brings in predictive analysis. So if you turn on Smart Drive technology, it's going to, you have preset thresholds for things like ECC corrections, head mispositioning, voltage variations. So the Smart Drive can report errors that are not catastrophic, but would show a trend towards drive failure. So if you're having more ECC hits and you're having to do a lot more error correction, that's because the data coming off and being read by the heads isn't as robust, so it's having to do more correction. This would logically lead to a forecasted drive failure where eventually ECC can't overcome the data problems that it's having. Maximum transfer rate was 150 megabytes per second, and two types of connectors were introduced for internal cabling: single port and quad port connectors. The drive always uses a single. SATA 2 built on that. We pumped it up. We doubled our transfer rate. They came up with a new latching cable connector for the back of the drives. The old SATA 1 connectors just kind of slid in, and they had a propensity to back themselves out over time and cause intermittent failures. And they also introduced a new feature called NCQ, or native command queuing. SATA 1, you issued a read command, the drive went ahead, executed the command, and returned the data. Same thing with writes. You'd say, here's what you need to write, and it would write it and say I was done. SATA 2 introduced command queuing, which now allows the drive to take multiple commands in a row, multiple read commands, or mixed and matched read and write commands, and queue them up, which frees up the controller from having to constantly talk to that drive every single time. So it makes the bus structure more efficient, and it allows the drives to operate more efficiently. And they added in new power features. The world is green. Green standby and spin down commands were added to the SATA 2 command set to enable control of drives when they're not being used, either by policy or by command. And these green features, just as a sidebar, the controller has to support these as well. You can have a green drive, but if you don't have a controller that supports it, you're not going to be able to use those features. SATA 3 is where we're at today. We can call it 6G, we can call it 600, we can call it SATA 3. We're going to call it SATA 3. We bumped her up to 600 megabytes. There's a new provision for a tiny connector for 1.8-inch drives. The reason is the 1.8 drives are 4-inch drives, very small, about the size of a matchbox, are forecast to proliferate in all types of appliances, anything that you can think of. Today, cars have 2.5-inch drives in them. Later on, they're going to have 1.8. Even things like refrigerators and stoves will start to carry small drives everywhere that they're at.